Yeah, good evening, children. Let's get started. So this is the first question for today's class. A hollow sphere of external and internal diameters, 8 centimeter and 4 centimeter respectively, is melted into a cone of base diameter 8 centimeter. Find the height of the cone. So what's happening here? One solid is converted to another solid. It's a hollow sphere. It's a hollow sphere. So this solid is made of some metal. That is why it's melted and recast into a cone. Correct? So this hollow sphere is made of, see, if it was made of wood, it's not possible to convert it to a cone, because when you burn wood, it becomes ash. You cannot make it something else again. So this is probably made of some metal. So this hollow sphere made of some metal is melted and recast into a cone. So one solid is taking the shape of another solid. So the volumes will be the same. When one solid is melted and recast into another solid, their volumes will be the same. All right. Good evening, Danya.
Good evening, ma'am.
So when one solid is melted and recast into another solid, their volumes will be the same. Their volumes will be the same. So the volume of the hollow sphere will be equal to the volume of the cone. So see here. Yeah. So volume of the hollow sphere, volume of the hollow sphere will be equal to the volume of the cone. All right. Now, what's the formula to find the volume of a hollow sphere? 4 by 3 pi capital R cubed minus small r cubed is equal to volume of cone 1 by 3 pi. Again, we have an R here, so we can say R1 square H, because we already have small letter R here. So we'll call this R1. So just substitute the values. Simply substitute the values. So you don't write down now. Pi gets cancelled on both the sides. 3 gets cancelled on both the sides. All right. So 4 into, what is the value of capital R? Diameter, that is 4. 4 cube minus, what's the value of small r? 2 cube is equal to the radius of the cone. Diameter is 8. So radius is 4. Correct? So 4 square, or you can write 4 into 4 into h. Now we'll have to solve this and find the value of h, and that will be the height of the cone. So see here. Have we done this, children? Look at the questions. No, right?
Excuse me, ma'am.
Any? No, right? Okay. Yeah.
Ma'am, excuse me, ma'am.
So you can see your children now what is given about the hollow sphere. The diameter is given. So you can represent that by capital D. Capital D is equal to 8 centimeters. That is the external diameter. So the external diameter is 8 centimeters. So the external radius will be 8 by 2, 4 centimeters. The internal diameter, small d, is 4 centimeters. So the internal radius will be 4 by 2, 2 centimeters. So this is about the hollow sphere. What about the cone? The radius is given, the diameter is given. So we call it the diameter is 8 centimeters. Radius, since we already have R here, we'll call this R1. R1 is equal to diameter by 2, 8 by 2, 4 centimeters. But we have to find the height of the cone. The question is to find the height of the cone. So H is equal to question mark. You don't have to say H1 because this is R1. You don't have to say H1. There is no H for a sphere here, right? Here in the sphere, we don't have H. So you can just use H. You can also call it H1 if you want. If you want it to be like R1, H1, you can call it H1. That's your choice. So this is what you should write first. Volume of the cone is equal to the volume of the hollow sphere, or the other way around. Volume of the hollow sphere is equal to the volume of the cone. Any order. I have written the volume of the cone first because we have to find H, no? So whatever is to be found, that part I'm writing first. That's all. You can write it the other way also. So the volume of the cone is equal to the volume of the hollow sphere because all the material in the hollow sphere is melted and it's now in the cone. All that material which was in the hollow sphere is melted and now it is in the form of a cone. So their volumes will be the same. You must write this in words first. Once you write this, the rest will follow. What's the formula to find the volume of a cone? 1 by 3 pi R1 square H. Hollow sphere 4 by 3 pi R cube minus R cube. Now we have all the values. Substitute. We have all the values. So you can substitute. Actually, you can substitute here itself. What is R1? What happens to 3 gets cancelled on both the sides. Pi gets cancelled on both the sides. What is R1? 4. So you can write 4 into 4 here itself. 4 into 4 into H, we do not know, is equal to 4 into, oh, maybe first I just cancelled. 1 minute. In the first step, no, I've just cancelled. I've not substituted any value there.
Ma'am?
So here in the first step, I've just cancelled. 3 and 3 gets cancelled. Pi and pi gets cancelled. So I've written the remaining R1 square H is equal to 4 into R cube minus R cube. Then substitute the values. Work and find the value of H. And the height of the cone is 14 centimeters. Tanya understood? Tanishka and Tanya understood? Good evening, Tanishka.
Screen is not shared, ma'am.
Yeah, class. Easy? Yes. Finish writing, children? What about you? Arjun? Done. Look at the next one. A solid sphere of radius 3 centimeters is melted and then cast into small spherical balls, each of diameter 0.6 centimeters. Let's tabulate the information given. So what are the two solids here? We have a solid sphere. We have one solid sphere. This is melted and recast into many small spherical balls. So that's also a sphere. Okay, small. This is a solid sphere. This is small spherical balls. All right. What is the radius of the solid sphere? 3 centimeters. It's a solid sphere. There is nothing like small r and capital R. It's just 1 r. So radius is equal to 3 centimeters. What about the smaller spheres? Diameter is 0.6 centimeters. So what is the radius? 0.6 by 2, which is 0.3 centimeters. Or you can write 3 by 10 also if you want. If you want a fraction, then you can write 3 by 10 also. Now, all the material that is in the solid sphere is now in all these small spherical balls. So we do not know how many spherical balls are made. So let the number of small spherical balls obtained. Sorry, that's obtained. Okay, obtained. Bn. let the number of small spherical balls obtained be n. Now, the volume of all the n spherical balls, the volume of all the n small spherical balls is equal to the volume of the solid sphere, is equal to the volume of the solid sphere. In the earlier question, one solid, in the earlier question, one hollow sphere was converted into a cone. One thing is converted into another thing, only one. Here, one solid sphere is melted and it's recast into many identical smaller spheres. One solid sphere is melted and recast into a number of identical smaller spheres. Identical, that's very important. It's not given, but you have to understand they have to be identical. Otherwise, we cannot find. Got it? So what will be, what's the equation in words? Volume of all the smaller spheres will be equal to the volume of that solid sphere. The volume of all the small spheres, all the n small spheres will be equal to the volume of that big solid sphere. That's the equation. So now write the formula below that. Substitute the values given and find the unknown. That's all. So see here. We'll first understand. Please see the screen. So volume of all the small spherical balls is equal to the volume of the solid sphere. Let the number of spherical balls obtained be n. Okay, let the number of spherical balls obtained be n. So volume of all the small spherical balls is equal to the volume of the solid sphere. So what is the volume of one spherical ball? 4 by 3 pi r cube. 4 by 3 pi r cube. All the small n into 4 by 3 pi r cube. See, like if you have 5, the volume of 1 is 4 by 3 pi r cube. If you have 5 into 4 by 3 pi r cube. 1 is this one, 4 by 3 pi r cube. Like that, n we had. So n into 4 by 3 pi r cube. All right. Okay. So, yeah, this is the volume of all the small spherical balls. And this is the volume of the solid sphere, 4 by 3 pi capital R cube. That's how we're differentiating. For the smaller ones, we're using small r. For the big one solid sphere, we're using capital R. Now, what gets cancelled on both the sides? 4 by 3 gets cancelled. Pi and pi gets cancelled. So what is remaining? N r cubed is equal to r cubed. N we don't know. We have to find the number of balls thus obtained. We have to find n. So n is n only. Okay, what is r for the small spherical balls? 0.3. 0.3. And the big one, radius of the big one, 3. So substitute and find the value of n. All right. See, you can use, instead of 0.3, you can use 3 by 10, 3 by 10, 3 by 10. So that working is your choice. You do however it is comfortable for you. All right. Yeah. Start working. Tanishka and Danya.
Ma'am, screen is not shared, ma'am.
Yeah, Danya and Tanishka, try to speak up now.
Ma'am, are we audible now?
Am I audible?
Yes, ma'am.
No, because my volume is full. See here. What did you say? Tanya?
I think Dani tried to say something.
Yeah, she was trying to say something, but she's not audible to us. Please type your children in the meetings chat. Am I audible to you, Tanishka and Danya? Or turn on your video and just show a thumbs up. Okay, I'm audible. Okay, but I can't hear you. Okay, Tanishka also says I'm audible. But why I'm not able to hear both of you, I don't know. Can you see my screen? Can you see my screen? Okay, fine. All right, Danya and Tanishka, please write down. This was the first one. You can take a screenshot. 1 minute. Let me just clear something. 1 minute. Yeah, now take a screenshot. Now take a screenshot of the first one, children. I hope it's done. Yeah, this is the second one. Please work this. All right, there's the next one. How many spherical bullets? See, again, the solid is a sphere. How many spherical bullets, all right, can be made out of a solid cube? So the two things here are a sphere How many spherical bullets? Okay, so many spheres. Okay, the bullets are in the shape of a sphere and the other solid is a cube. So how many spherical spherical bullets can be made out of a solid cube of lead? Lead is the material. Lead is the material. Solid cube of lead whose edge measures 44 centimeters. So for the solid cube, we only need the edge. Because for a cube, the length is equal to the breadth is equal to the height. And the edge is given to be 44. So you can find anything for a cube, meaning area, volume, anything you want. So for the cube, we have the edge. And now for the bullets, the diameter of the bullet, the diameter of each bullet is given to be 4 centimeters. So for the sphere, you only need the radius. For the sphere, you only need the radius. So we have both. Now the question is how many? Who can tell me the equation? Yes, Arjun. What's the equation in words? Volume of? No, volume will be equal to volume only. Volume of the solid cube is equal to volume of, very good. No, he's got volume of total volume of bullets, all the spherical bullets, correct? Repeat. Bullets, very good. Yes, in your words, Madhumita.
Volume of the spherical, volume of the cube is equal to the volume of all the spherical.
All the spherical bullets. Okay, very good. Since I'm not, Tanishka and Danya, I'm sorry, you're not audible, so I'm not asking you. I hope you know this. So this is what it is, children. I'm not explaining. You can understand. Please take down. This 21 is that 3 into 7. I've multiplied into 2. This is the 3 into 7. This one. Correct? Done, boys? Arjun, you have trouble with cancelling, is it? Simplifying? Yeah? Yeah, we'll do it together. See here. Let's start here, okay? So 4 ones are, 4 11s are. Watch the screen, you can do it later. See, 4 ones are, 4 11s are. 11 ones are, 11 twos are. Okay? Then again, 2 ones are 222 times. 2 ones are, 2 11s are. Then you can cancel this 2 twos are 4, right? And 4 11s are 44, correct? So now what is remaining? Denominator is 1. Denominator is 1. In the numerator, we have 11 into 11 into 21. 11 into 11 into 21. 11 into 11 is 121 into 21. So 121, 242 when you multiply. So 1452. Yeah, 2541. All right. Yeah, this is a test. Let's see who can do this first with the correct answer. Tanya and Tanishka, this is a test. You can send your picture on WhatsApp. Not able to hear you, so you can send your answer on WhatsApp if you finish. Yes, of course. Please write the question, children. Okay, Tanishka, you want the second question, is it? Finish writing the question, children? This one? Yeah. No, Tanishka wants a second question, so I just want to take her to that slide. Yes, Tanishka, you wanted the second answer. You can see the question and answer here. Tanishka, you can see the question and answer here. Please take a screenshot. Yeah, what is? Spherical means sphere. Lead is the material. Your pencil lead, that material. Spherical lead shots. Have you seen Cadbury's shots? Yeah. Spherical in shape. Shots. Okay, like how marble. You play marbles. Yes. You have marble. Yeah. So lead shots. Spherical is what is important for you. It's a sphere. So spherical, like cuboid means cuboidal. Spherical. Lead is the material. Lead shots. We can't find you. Let me check it out. I'm so happy that all of you know how to get started. Very good. Tanya and Tanishka? And the answer is 1,500.
Calculation.
Yeah, check. The answer is 1,500. See if you're getting.
Uh, 4/3 pi r square is
Oh.
I missed 121 by 10. So
Tanya and Tanishka can share pictures on WhatsApp if you finished. Sorry? 1,500 is the correct answer. Very good. Got it? Very good. 1,500 is the correct answer. Yeah, please. Very good. Yeah, Danya, see, in order to save time, you should work this. Your answer is right. You worked it correctly. But what I suggest is you work it simultaneously like this with this equation. Volume of all the spherical lead shots is equal to the volume of the uh, rectangular solid. Because see now on either sides, when you have pi, the value of pi, meaning if you have pi in the formula, you can cancel. Like we did in the earlier cases, on either sides, if you have the same quantity, you can cancel them. And also, when you do LBH, you're simply spending time multiplying 66, 42, and 21. And again, when you find the volume of each sphere, you're spending time multiplying. And then you have to divide also. When you find it individually, volume of cuboid, LBH, you'll have to multiply and get the answer. So multiplication takes time. Again, volume of sphere, you will have to multiply and get the value. And then again, you'll have to divide to find the number of shots. All this is time consuming, maybe one minute extra. But in the exam, it matters when you're doing a exam for 80 marks. 5 minutes really matters. So when you do it like this, you save time because you're just simplifying, you're just canceling the numbers in the numerator and denominator. So you can finish working this faster. When you work it simultaneously like this, you can complete the answer faster because you're saving time on multiplication and division. Got it, Danya? All right. Good. Yeah, children. So don't find, the volume of the cuboid separately, then the volume of the, spherical lead shot, and then divide. You'll be spending time there. Volume of the cuboid L into B into F, you'll have to multiply and get the answer. Then the other thing you'll have to again cancel and all then multiply, get the answer. Then you'll have to divide. So you'll be spending a lot of time in calculating. When you do it like this, it's easier to cancel, no? Numbers in the numerator and denominator, it's easy to cancel. And once for all, you multiply and get the answer. So you're not multiplying, and then dividing again. This is less time consuming. So please work it like this. All right, so that's about in this presentation. Yeah. Please, this is a simple one. Write down the question, take down the answer also, go through the answer, take down the answer, and I'll ask each one of you to explain a few steps. Yeah. Yeah, please take down the question and write the answer, children. Tanya and Tanishka, please understand. And then write down the answer. Finish working. Danya and Tanishka, kindly text. Okay, okay, both of you finished working. All right. Yes, here. Okay. Yeah, we'll start with Arjun. Yes, Arjun. Louder. Just explain what's on the screen. You haven't said completed. Okay. Okay, you start. Yeah. What's given? Louder. Ratio of what? Ratio of their volumes. 64 is to 27. Okay, so how do you express that? How do you express that like this? How do you express the ratio? X by Y meaning X is to Y. Okay, so the ratio of the volume. So V1 by V2. What is V1? Correct. First sphere. What is V2? The volume of the second sphere. So since the ratio is given, we write V1 by V2 is equal to 64 by 27. Very good. Then okay. Correct. How have we differentiated the volumes? For V1, we have used R1. And for V2, we've used R2 because both are spheres and both have radii. So R1 and R2. So 4 by 3 pi R1 cubed by 4 by 3 pi R2 cubed is equal to 64 by 27. Okay, next. Pi also gets cancelled. And then we have so R1, so it is like A cubed by B cubed, which can be written as A by B the whole cubed. Correct? So R1 cubed by R2 cubed. I have written it as R1 by R2 the whole cubed. A cube by B cubed is A by B the whole cube. So like that, R1 cubed by R2 cubed is equal to R1 by R2 the whole cube is equal to 64 by 27. So now 8th standard, A cube is equal to 27. What is A? A is equal to cube root of 27. So similarly here, R1 by R2 will be equal to, Raja? Not root cube. I don't know if we can say like that. Cube root of. Yeah, cube root of. Yeah. What's which is 4 by 3 because the cube root of 64 is 4 and the cube root of 27 is 3. So R1 by R2 is 4 by 3. Does that mean R1 is 4 centimeter? No. My question is, see, R1 by R2 is equal to 4 by 3. So can I say R1 is 4 centimeters and R2 is 3 centimeters? No. Correct. So you cannot say that the radii of the two spheres are 4 centimeters and 3 centimeters. For example, I'm 45 years old. You're 15 years old, say. Okay. So what is the ratio of 45 is to 15? 3 is to 1. 3 is to 1. So 3 is to 1 is the ratio of our ages. That doesn't mean that I'm 3 years old and you are 1 year old. The ratio, teacher's age by student's age. Teacher's age by student's age is equal to 45 by 15, which is 3 by 1. So teacher's age by student's age is 3 by 1. That doesn't mean that I'm 3 years old and you're 1 year old. No. So my age is 3x, 3 into 15, 45. And your age is 1x, 1 into 15, 15 years. All right. So you were right. So it's not 4 and 3, it's 4x and 3x. Correct. So let R1 be 4x and R2 be 3x. Then what is given? Continue, Arjun. why have we written R1 plus R2 is 7? The sum of the, it's given that the sum of the radii is 7 centimeters. All right. So sum meaning R1 plus R2. Difference meaning R1 minus R2. Yeah. How R1 is 4? 4x. So 4x means 4 into 1. 4 and here 3 into 1, 3. So it's actually 4. So in this case, we are getting the same value, 4 and 3. 4 and 3. That's because x is 1. But that doesn't mean every time if the ratios, whatever is the ratio, the same will be the values. No. Here because x is 1, we are getting the same thing, 4 and 3 here, 4 and 3 here. Okay, then Madhumita, continue. Okay, you want to complete it? Yeah, go ahead. Okay, I'll give her the next one.
So S1 and S2 is 4 by R1 square and 4 by R square.
But why minus? Why not plus? Because you have to find the difference of their surface areas. So S1 minus S2 we have to find. Yeah. Then
We have 4 by R1 minus R2 square.
okay.
Then
Then what is this suddenly?
A plus B and
Yeah, correct. Complete the identity. A plus B, A minus B is what?
A minus C whole square.
No.
A square minus square. A plus B and A.
He helped you? No. Okay. A square minus B square is equal to A plus B into A minus B. So we have here R1 square minus R2 square, like A square minus B square. R1 square minus R2 square. A square minus, see, not that you should use the formula. You can substitute straight away also. 4 by 3 pi, what is that? R1 square is 4 square minus 3 square. You can do this. You can do this itself. Not that you should use the formula here. What is R1? 4. What is R2? See here. Not that you should use identity. 4 by 3 into pi is 22 by 7. Into what is R1 square, 4 square, 16. Minus R2 square, 3 square, 9. You can do it like this also. 4 by 3 into 22 by 7 into, the difference is 7. So 7 and 7 gets cancelled. And what is this? What about this 3? We went wrong here. Oh, it's not 4 by 3. It's 4 pi r square. Sorry. I wrote 4 by 3. 4 pi r square, r1 square minus r2 square, right? So 4 into 22 by 7 into 16 minus 9. So 4 into 22 by 7 into 7. So 7 cancels and 88. You can do it like this itself. Not that we should use the identity here.
And in this case, the numbers are small, so it's easy to calculate.
Easy to calculate. Yeah, exactly. Here the numbers are small. So it's fine, 1697. If the numbers are large, this will be more useful. Using the identity will be useful, correct? When the numbers are large, the identity will be useful. Okay. So, yeah, R1 plus R2 is, Arjun, R1 plus R2 is 4 plus 3, 7. And R1 minus R2 is 4 minus 3, 1. Now 7 and 7 gets cancelled and it's 88. Very good. I'm sure Madhumita also understood as much as they. Very good. Tanya and Tanishka, any questions? Oh, I don't know why today we're not audible. Fine, girls? Very good. No doubts clear, ma'am. Very good. All right, let's see the next one. Three solid spheres of iron Okay, so 3 solid spheres of iron whose diameters are 2 centimeters, 12 centimeters, and 16 centimeters, respectively, are melted into a single solid sphere. So 3 spheres of different sizes, because you can see their diameters are different. So 3 spheres of different sizes, they're melted. So it's made of the same material iron. It's made of the same material iron. All the 3 spheres are made of the same material iron. So these 3 are melted, and all the iron is now used to make one that is single solid sphere. All right, we don't know the radius of this new sphere form. That's what we have to find. We have to find the radius of the new sphere, new big sphere form. 3 spheres are now one sphere. 3 spheres become one big sphere now. We know the radius of all the 3 spheres. Diameters we know, so we know the radius. So using this information, we have to find the radius of that one big sphere. All right. It's easy, but I just want to show. Or try this, children. Try this. Tanya and Tanishka, please try this. Write down the question first, children. Yeah, Dhanya and Tanishka. If you're finished, you can share your picture. Okay, I've not received the answer from anybody. I think you're all using a very lengthy procedure. So see here, it's very, very simple. You can see, I'll just try to work it fast so that you understand that it can be got so quickly. Okay. If I don't make any mistake while working. So now see here, volume of the big sphere. Okay, I'll just call it the big sphere. Don't write anything now. Volume of the big sphere is equal to volume of all all the three small spheres. All right. So I'll just write, I won't talk anything, okay? You'll all understand. So see here. All of us can go do it. All of us can do it. That's all it is. But what have we been doing? We've been substituting the values everywhere. Pi 22/7, R1, everywhere. So you'll take a longer time. So this is how we are expected to do.
On the cross cancel both the sides idea that strike me, but I didn't take it out of common.
Yeah.
I was not sure if I could strike it when it's.
No, no.
plus.
Okay, understood. So you knew that you realized that you have to cancel, but you didn't know how to go about it. You have to take out 4/3 pi common. Understood, all of you? Now you have no. So what your doubt is? What is the formula to find the volume of all the three spheres? Ah. Okay. Is it clear? Is it clear? So what is the volume of the big sphere here? 4/3 pi capital R cube. That you should decide first itself. There are three small spheres and one big sphere. So let that big sphere be R, capital R, and the small spheres be R1, R2, R3. All spheres only. So 4/3 pi R1 cube for one sphere. The other one 4/3 pi R2 cube. The third one 4/3 pi R3 cube is equal to 4/3 pi capital R cube. Now take out 4/3 common on both sides, cancel. Understand? Yeah, now work. Instead of this, you can also write is equal to volume of sphere 1 plus volume of sphere 2. See, instead of this line, children, all of you please write this one is equal to volume of sphere 1 plus volume of sphere 2 plus volume of sphere 3. So why you're distracted today? You're thinking of something else? You're tired? No. You're not able to concentrate. Yes? So 8th standard will wind up all classes. Now, if we want to do well, if you want to like do fairly okay in academics and concentrate on your extracurriculars, fine. See, the choice is yours. If you want to do super good in your academics, meaning you want to do your best, improve every day, then you have to study every evening. You have to study every evening. So you are not doing that, what is that? Archery, then also you go for practice, and then when you have to go for competitions, you spend a lot of time with that. So that's difficult. You spend time. Oh, correct. That's also there. Correct. Yeah. Correct. So you should sit and talk to your parents and plan how you should go about it. Correct. So for you, the problem is the time taken to travel to school and back from school. Correct. Okay, girls, I hope it's clear. Online girls. Class here, any questions? Arjun? Madhumita? All right, very good. So remember this. We need to take out 4/3 4/3 pi common and cancel it on either sides. And then the whole thing becomes very simple. Yeah. The internal and external diameters of a hollow hemispherical vessel. That means half a coconut. Imagine half of a coconut. Imagine a coconut which is a perfect sphere. Right?
Not a bowl.
Bowl. Yeah. I'll just show. Yeah, this one. But it's like this. This is a bowl. This is a bowl. This is also a bowl. See here. This one is a bowl where the wall is thin. There's only one radius. This one is a bowl in which the wall is thin. So from the center, there's only one radius. There is nothing like internal and external radius. There's only one internal radius. The external radius is also almost the same as the internal radius. The wall is very thin. The wall of this vessel is very thin. So from the center to the inner wall is radius. From the center to the outer wall, it's very thin. The wall is thin. So it's almost, the value of capital R is also almost the same as small r. So this is a vessel where the wall is very thin. So there's only one radius, R. Look at this bowl. Excuse me. Look at this vessel. The wall is thick. So you have one small r and capital R. From the center to the inner wall, small r. From the center to the outer wall, capital R. But this R is not only this portion. From the center to the inner wall, a small r. From the center to the outer wall till here, this one is capital R. What is this portion? W, width. That is the width plus the small r is capital R. The width or capital R is equal to this inner radius plus the width. See here. This is the width. This is W. From here to here is W. So what is capital R? What is capital R? Inner radius plus W. Inner radius plus width is equal to the outer radius. Now, if you have to paint a vessel like this, Tell me the surfaces available for painting. If you have to paint a vessel like this, it's hollow inside. Yeah, coconut, right? It's hollow inside. Here you can pour something inside. Okay. Now tell me, what are the surfaces available to be painted? Yeah, what are the surfaces available to be painted?
On the outer portion.
Yes, what do you call that? Curved surface area. What curved surface area? Inside or outside? Outside. So you have the outer curved surface area. Then inside, do you have curved surface area?
Yes,
Yeah.
ma'am, but we didn't paint.
No, you have to paint the vessel all over. It's not a coconut now. You have to paint it all over. So inside also this curved surface area. Okay, so then where else can you paint?
The outer ring.
The ring on the top. The ring on the top. Exactly. These are three portions, or these are the three surfaces which have to be painted. So the three surfaces which have to be painted are the outer curved surface area, the inner curved surface area, and the area of this ring. This one, which is a ring. This one on the top. You will have to paint the inner CSA, the outer CSA, and the area of the ring on the top. Okay, so this is the outer CSA. This is the outer CSA outside. Then inside the inner CSA. Inner CSA you have to paint. And then this ring on the top. This one you'll have to paint. So these are three surfaces which you have to paint. Now coming back to that question. The internal and external diameters of a hollow hemispherical vessel. What we just saw is a hollow hemispherical vessel. Okay, the internal and external diameters of a hollow hemispherical vessel are given to you. Find the cost of painting the vessel all over. That is inner CSA, outer CSA, and the ring on the top. At the rate of 35 paise per centimeter square. So what should you do? You should find the inner CSA, the outer CSA, the area of the ring, or add all the three areas and multiply it with the rate to find the total cost. What's the formula, Arjun? CSA of a hemisphere. 2 pi?
2 pi r.
Very good. 2 pi r square. You have memorized all the formula? Sorry? Okay, okay. Is he right? He may be wrong. If it's right also, I'll say correct. If it's wrong also, I'll say it's correct. No, you tell me, is he right or wrong? You don't know. You have not memorized. Next class will come on the dais and you'll say all the formulae. Yeah, you?
It's right.
2 pi r. You're sure? Very good. 2 pi r square. All right. Very good. Arjun, good. Raja, please memorize the formula. Correct. So see here, children. So see here. Find the inner CSA. Find the inner CSA 2 pi small r square. Then find the outer CSA 2 pi capital R square. And then find the area of the ring on the top, pi r square minus r square. And you can see here, I have not used the value of pi at all because I just want to save time in calculating. I know I'm going to get this answer in pi, this one also in pi, and this one also in pi. So I don't use the value. Pi is 22 by 7, but I don't want to use that value because again, it's time consuming to calculate when you have 22 by 7. So what I do is I don't substitute the value of pi. I just have it as pi. 2 into pi into, only for r I substitute 10 square. So 200 pi. The next one is 392 pi. The next one is 96 pi. Now the total area to be painted is 200 pi plus 392 pi plus 96 pi. It's like 200x plus 392x 392x plus 96x. How will you add? Add everything and just put an x after that, right? What is 2x plus 3x plus 4x?
9x.
9x. 9x. So like that, just add. You get 688 pi. 688 pi. Now the cost of painting is area to be painted into rate. Area to be painted is 688 pi. Into the rate is rupees 35 by 100 because 35 paise. So 35 by 100 rupees. Correct? Now use the value of pi. See here 688 into 22 by 7 into this is 5 sevens are 5 20s are. So 7 by 20. So now see 7 and 7 gets cancelled. And then on simplifying, you get 756.8 rupees. So you're saving so much time. See, had you used 2 into 22 by 7 into 100, probably you would have tried to multiply all this 222, 44 into 100, so 4,400 by 7. You understand? So maybe you'd have spent all the time there. And then who knows, maybe you thought you should also divide like this. So you save a lot of time. Don't use the value of pi. Work it like this. Do not use the value of pi here. All right.
Exams on Monday as well, and have balance service.
Yeah. Okay. We'll do that on Sunday in the revision class. Okay. From NCRT or outside NCRT?
From
NCRT. Okay. I think then I have the presentation ready. Have you learned circles in school? Circles. Not yet. It's going on. Okay. Then I think I'll help you personally because I can't do it for the class. They'll not understand. Then I will help you personally. Sorry?
How?
Maybe on a meeting, Teams meeting. Will that be okay?
Yes, ma'am.
Yeah, we can do that. Monday you have the exam, is it?
Yes. I want to school tomorrow, so I'll be free tomorrow and
Tomorrow.
then.
Okay, fine. Monday morning session is the exam.
Tomorrow.
Monday you have full working day.
Okay, but we write the exam in the evening, so we'll have time for revision.
Oh, yeah, please. Yeah, thank you. Bye. You live close by, yeah? You live close by?
Yeah.
And where's the online session it is?
Yeah.
The class is online. Okay, yeah, see. You finished writing this one? Not completed, no? I'll send the picture. Yeah, see you. Okay, I've sent the picture. Please complete it. Okay. Right. Yeah, see you.
Completed.
Okay, yeah, good. Bye.
Bye.
Yeah, good night. Dani and Tanishka? Understood this answer? Any questions? Completed, no doubts. All right. All right, Tanishka and Danya. I think in one of the earlier classes, I'd asked you to take down the screen, take screenshots of 2 answers and asked you to complete that. And I said we'll discuss it later, right? No, not in your class. Was it 10th standard?
I didn't write anything.
I didn't send on WhatsApp.
No, I usually take screenshots of every slide in case of a mistake.
Okay. Let me know. Maybe you can go home and check. Let me know. Now for this class, take a picture of this one and complete this at home, children. This one alone. This one alone. I'll send this picture on. I'll send this picture in the group. Please complete this. And remind me that we have to discuss this one in the next class. Let me know about the others also. Okay, I think two answers and asked you to take a picture, and I did not explain them. I remember. I'm only confused if it was your batch or 10th standard. All right, Danya and Tanishka, that's it for today's session. I've sent one image on WhatsApp. Please complete that, and we'll discuss that in the next class. All right, Danya and Tanishka, thank you so much. Good night. You may leave the call.